Chapter number 8, Winds, Storms and Cyclones, Class 7th. So let's start. Odisha was hit by a cyclone with wind speed of 200 km per hour on 18 October 1999. The cyclone smashed 45,000 houses, making 7 lakh people homeless. On 29 October the same year, a second cyclone with wind speed of 260 km per hour hit Odisha again. It was accompanied by water waves about 9 meters high. Thousands of people lost their lives. Property worth crores of rupees was destroyed. The cyclone affected agriculture, transport, communication, and electricity supply. But what are cyclones? How are they formed? Why are they so destructive? In this chapter, we shall seek answers to some of these questions. We begin with some activities involving air. These activities will clarify some basic features concerning a cyclone. Before we begin, remember that the moving air is called the wind. 8.1 Air exerts pressure. Activity 8.1 Whenever an activity involves heating, be very careful. It is advised that such activities are performed in the presence of an elderly person from your family, or carry out these activities in the presence of your teacher. You need to boil water in the following activity. Take a tin can with a lid. Fill it approximately half with water. Heat the can on a candle flame till the water boils. Let the water boil for a few minutes. Blow out the candle. Immediately put the lid tightly on the can. Be careful in handling the hot can. Put the can carefully in a shallow metallic vessel or a wash basin. Pour fresh water over the can. What happens to the shape of the can? Can you guess why the shape of the can gets distorted? If you cannot get a tin can, take a soft plastic bottle. Fill it with hot water. Empty the bottle and immediately cap it tightly. Place the bottle under running water. Recall now some of your experiences. When you fly a kite, does the wind coming from your back help? If you are in a boat, is it easier to row it if there is wind coming from behind you? Do you find it difficult to ride a bicycle against the direction of the wind? You know that we have to fill air into the bicycle tube to keep it tight. Also, you know that a bicycle tube overfilled with air may burst. What is the air doing inside the tube? Discuss with your friends how the air in the bicycle tube keep it in shape. All these experiences show that the air exerts pressure. It is due to this pressure that the leaves of trees, banners or flags flutter when the wind is blowing. You can list some more experiences which show that the air has pressure. Let us now try to explain why the can gets distorted as water is poured over the can. Some steam in the can condenses into water, reducing the amount of air inside. The pressure of air inside the can decreases than the pressure exerted by the air from outside the can. As a result, the can gets compressed. This activity again confirms that air exerts pressure. 8.2 High speed winds are accompanied by reduced air pressure. Activity 8.2 Crumple a small piece of paper into a ball of size smaller than the mouth of an empty bottle. Hold the empty bottle on its side and place the paper ball just inside its mouth. Now try to blow on the ball to force it into the bottle. Try the activity with bottles of different sizes. Challenge your friends if they can force the paper ball in by blowing into the bottle. Paheli and Bujo are thinking about the following question. Why is it difficult to force the paper ball into the bottle? Activity 8.3. Blow the balloons. Take two balloons of approximately equal size. Put a little water into the balloons. Blow up both the balloons and tie each one to a string. Hang the balloons 8 to 10 cm apart on a cycle spoke or a stick. Blow in the space between the balloons. What did you expect? What happens? Try different ways of blowing on the balloons to see what happens. Activity 8.4. Can you blow and lift? Hold a strip of paper 20 cm long and 3 cm wide between your thumb and forefinger as shown in the figure 8.5. Now blow over the paper. Paheli thinks that the strip will be lifted up. Bujo thinks that the strip will bend down. What do you think will happen to the paper? Let us try to understand the observations in activities 8.2, 8.3 and 8.4. Were the observations along the lines you thought? Do you get the feeling that the increased wind speed is accompanied by a reduced air pressure? When we blow into the mouth of the bottle, the air near the mouth has higher speed. This decreases the pressure there. The air pressure inside the bottle is higher than near the mouth. The air inside the bottle pushes the ball out. In activity 8.3, you saw that when you blew between the balloons, they moved towards each other. How could this happen? This could happen if the pressure of air between the balloons were somehow reduced. The pressure outside the balloons would then push them towards each other. In activity 8.4, you saw that when you blew over the paper strip, it went upwards. Again, this could happen if blowing over the paper reduced the air pressure above the strip. We see that the increased wind speed is indeed accompanied by a reduced air pressure. Can you imagine what would happen if high speed winds blew over the roofs of buildings? If the roofs were weak, they could be lifted and blown away. If you have any such experience, share it with your friends. Let us try to understand how winds are produced, how they bring rain, and how they can be destructive sometimes. You already know that when air moves, it is called wind. Air moves from the region where the air pressure is high to the region where the pressure is low. The greater the difference in pressure, the faster the air moves. But how are the pressure differences created in nature? Is the difference in temperature involved? The following activities will help you to understand this. 8.3. Air expands on heating. Activity 8.5. Take a boiling tube, stretch a balloon tightly over the neck of the tube. You can use a tape to make it tight. Pour some hot water in a beaker. Insert the boiling tube with the balloon in the hot water. Observe for 2 to 3 minutes for any change in shape of the balloon. Take the tube out, let it cool down to the room temperature. Take some ice cold water in another beaker and place the tube with the balloon in cold water for 2 to 3 minutes. Observe the change in the shape of the balloon. Think and try to answer. What makes the balloon inflated when the boiling tube is placed in hot water? Why is the same balloon deflated when the tube is kept in cold water? Can we infer from the first observation that air expands on heating? Can you now state what happens to the air in the boiling tube when it cools down? The next activity is very interesting. This will make you understand more about hot air.